This week we're going to be going through the last of second order constant coefficient homogeneous linear ODEs. So that's where there's no driving term. There's only functions of y and its derivatives arranged linearly. You've learned to solve these by guessing a solution for y equals e to the xt. You plug that into your equation, you do some work, you find what's called a characteristic equation, or sometimes called an auxiliary equation, which you solve for eigenvalues. Now, these eigenvalues determine the type of solution. You've seen what happens when you get two distinct eigenvalues. You've seen what happens when you get two complex conjugate eigenvalues. Today, you're going to see what happens, or this week, you're going to see what happens when you've got one repeated eigenvalue. You've got to do a bit more work, and we'll learn about that in the lectures this week. And then we'll move on to handling inhomogeneous equations. These equations involve an explicit function of t alone. Now, this might be like a driving term for your equation. Let's say your equation models a car suspension. The function of time is the bumps in the road as you pass over the bumps. This complicates things, obviously. However, we can still solve by one of the most popular tools in mathematics, which is guessing. We'll learn the technique of undetermined coefficients, where we make a hypothesis about what the solution is going to look like, and we determine a bunch of constants, essentially, that bend our solution to fit the problem. So essentially, we guess, but we have some parameters that allow us flexibility in that guess, and then we determine what the parameters must be. So that's called the method of undetermined coefficients. Yeah, so that's this week.